Hello! So, today is time to do our Docker application automatic update for applications running in a Docker on the edge. So what I mean by that is, this is our little diagram, what we will be doing, but at the edge I mean 4G router. So in this case it's ICR-3232 and we have Docker running on this device and our application which does serve simple web page. The application is a Python application and we just Dockerize it for the purpose of this exercise. What it is my Python test application, very simple, and we are building it for a platform ARM v7 or v7, which is this. So let's have a look how we gonna automate the deployment on the routers, where every time we push new version of our application into Docker repository, it doesn't need to be the official Docker Hub. It can be your private repository or AWS, DigitalOcean, doesn't matter. Every time we push the new version, that the router will get it and apply it and run with it on its own, so no other interaction is needed there. Okay, so at the moment we do have running our Docker application version 107, which is the latest in my case, and let's see, so and we running a Docker version 2010.7. This is official Advantech router app, and it's fully supported. There's great documentation for it. So let's just see what we dealing with here on this specific unit, if we have any more containers and so on. So okay, now we have just this container which is up and running for 27 minutes. So let's start this again from scratch and then we move on updating it. So I'm gonna stop this. Here we go. Give it a few seconds for stopping. Let's. Okay, good. So what I'm gonna do, it stops, so I will remove it. As you can see, when I refresh this window, the application is no longer running, and it's obvious. So all done, no containers. So have a look at the images which we have on this unit at the moment. That's only one, and that's my application. So let's just demonstrate how to run Docker container. So in my case, I am setting restart policy unless stopped. My application is serving web page on port 8000, and the Python Flask runs by default on 5000. One more thing which I showed in last video is how to expose COM ports of the 4G router to your Docker application. So I could do it here, which is S0 is RS-232 and S1 is RS-485 on ICR-3232. So at the moment I just changed 3 parameters. One is our restart policy, another one is our web page interface or web interface for the application, and the last one is having a COM port exposed to our Docker. As you can see, I did not check the privileged parameter there. It's not needed for this case. So let's run with it. So let's run our Docker image. Wait a little bit. This will take a couple of the seconds. Done. It's running, so let's see if we get our web interface back. Still not up. Here we go. And our 107, it's up and running. Okay, so what we gonna do about our automatic update? So in this case, there are several ways of doing the same thing. This is proof of concept. It can be developed further. But how it solved in my case is I do have a startup script, which in essence tries to pull the image from your Docker repository with tag latest, and if it's new one, it applies it. If it's not, it doesn't do anything. That is our difference, or the way how we achieve this. So we have the script, and then we add a cron, the Linux scheduler command, which will run our script at some time interval. The important part of why I have done it this way is we create this feature, and this feature will become part of the configuration of the router. So when we gonna do our backup configuration, all that will be part of that file. That means that if we need to replace the unit or do a firmware update, it still will be, we will not wipe the feature out. If, for example, we would make this script manually on the file system and then just run it, so on. So this is really good, because if someone else will come and see the script here or this text, it will be obvious that something is happening, so they can investigate further and find out what's going on. Okay, so we have our 107 working, and we just find out that this is something wrong and we need to change the parameters. So we are not wanna make Greek coins anymore, we wanna make kangaroo coins. So let's update our application. So here it is, and we gonna make kangaroo coins, and let's bump up the version 108, save, and build the version 108. So important in here is, in my Docker command, is that we are using Docker build X, and our platform is ARM v7. So let's build this 108, and it's all built. It's pushed into our Docker repository, and we need to make tag it latest as well. latest. So let's do it now. This takes just few seconds as we just making a new tag. Let's have a look at our Docker repository. Okay, and we have version 108, and our latest tag is following this version, and our platform RV7. So let's look back to the router, the 4G router which we have. So this is still running 107 version. And if we look into system log, we see that our script is, trying to run every so often, and we either will need to wait for a new run of that script, or maybe we just gonna reboot the router, so the cron will start from that moment. So let's just reboot the router quickly. This is relatively fast on these units. It takes really those 30 seconds is very realistic time estimate there. So as you can see, this is obviously not running when we are rebooting, and let's wait for this to happen. In meanwhile, let's do the recap of what we are actually doing is when it's rebooted already. Okay, so what we are demonstrating in this exercise is having several routers or one, and the routers or router can run multiple Docker containers or Docker applications at once. So as we are progressing in development of those applications, we need optimal way of pushing forward new versions of those applications on the remote devices. This can be done manually, but at certain point it will become tedious and non-reliable, because people always can make a mistake, or something happens, or the people who actually know what to do are not available at the time, and so on. The other thing is that the software developer might not be familiar with our devices in the field. So for those guys might be difficult to do it, and you want to remove that obstacle in a way. So instead of software developer making the new version and then trying to apply it on those remote devices by themselves might be tricky. The other thing is maybe other department needs to do that, and again that will become just one thing extra which needs to be dealt with. So in our case, that's why we can easily move from version to version to version and don't really need to touch the end device. Okay, so the important part now is let's see how we end up in running our application. So, or automatic update. So we did have our router reboot, and let's see how that happened. Okay, here we go. So we are now in version 108, and we are making kangaroo coins, which is great. So what happened is the unit pulled. Let's look into exactly what happened. So unit ran our update script and pulled the new image from the Docker repository, which is latest. And as you can see, so there are now two Docker images. One, the older one, and the current version which we have. What that means is we have multiple containers as well. Oh, sorry, we have only one. My mistake. But what that means in our context is our update script is not production ready, because as we start updating our application over time, we will run out of the space on the physical router, so it would not work correctly any longer. So that means this script needs to be expanded to deal with all that eventualities to be ready for a production deployment. Either way, the important part what we show today is we do have a way of automatically updating Docker images or Docker applications on the edge 4G routers without human intervention. And I will see you in the next video.